Okay, so let's look at this typical question for linear law. Okay, so they gave you a table, an x and y table, and they gave you a original equation. Okay, so the first part, you are supposed to draw the graph. So if you need to draw the graph, you actually need a new table. So okay, if you remember the previous example that we went through, the first step, we actually got to linearize the equation first. Okay, so you can linearize first. Okay, the linearize will be useful for the second part. Okay, whether you linearize or not, it affects whether you're going to get your P and Q or not. Okay, then second step, you just supposed to get the new table. Okay, so I'm going to repeat the standard step. So first step, I'm going to do a linearization first. So the linearization is done here. So this is actually my step one. I do not need this to draw the new table, but it will help me to find the value of P and Q later on. So I do a linearization first. Okay, so what I did was I did a cross multiply, something like this. So I did a cross multiply, bearing in mind that this will be my capital Y and this will be my capital X. So when I'm doing my step one linearization, I must bear in mind that I wanted to have the capital Y and I wanted to have the capital X. So if you are not clear about your aim during linearization, you find that you always get stuck in this step. So after I cross multiply, okay, my target, this is my target. Okay, so my target is this one. So what I'm going to do is I shift this item over. I isolate my XY. After I isolate my XY, I bear in mind my aim is to get Y on my left side. So I go on to divide by X. So I divide both sides by X. And if you look carefully, after I gotten my both sides, dividing both sides by X, this is what I have gotten. I gotten this Y over X, which is my capital letter X. So I gotten my Y, I gotten my Y over X. So I reorganize my Y over X in such that this minus Q will be my gradient. So later on, I'll be using my gradient, the gradient from my graph, to find the value of Q. And this will be my Y-intercept. So this linearization steps is going to determine whether later on you'll be finding your P and Q or not. However, if I would like to draw the graph, I will need to have a new table. So this is my step 2. I will get a new table of my capital X and capital Y. So this one, you just have to take some time to punch your calculator out. Step 1, linearization. Step 2, new table. Then you supposed to draw out the graph. The drawing out can be quite difficult and quite time consuming because they will not be telling you the scale. You actually got to decide the scale based on your table. So this will be my capital Y and this will be my capital X. So if nothing goes wrong, you should have a straight line. So sometimes you might have a best fit or you have a line that is out, just a point that is out. So that's fine. Okay, so step 4. Okay, so now that I draw already, I'm going to go to part 2. How am I supposed to use the graph? Your job is to use the gradient from your graph. Use the gradient from your graph. So how are you going to get the gradient from your graph? You choose 2 points. Okay, so you choose 2 points. I can't remember which point that I chose. So I will not choose the table point. So I will choose the point. So if I think I chose something like 1.5 and 13.5. So I chose a point 1.5 and 13.5 here. So the point I choose will not be part of the table. It will be the straight line. The point should come from the straight line. Then I choose another 7.5, bracket 7.5. So don't choose from the table. You choose from your line. So I choose 2 points that I can read from the graph, and then I do my calculation for the gradient. So once I know the IU from the graph, I'm able to use a gradient, and the gradient is actually represented by minus Q. So that's why minus Q is equal to -1, and that's how I got my Q. That is the meaning of use your graph. You get 2 points from the graph, calculate the gradient, it will help you to find minus Q. But you must linearize first. If you don't, you will forever don't know how to find the value. Then I will need the intercept to help me to find P. So make sure your graph cuts the axis. So my graph cuts at 15. So from the graph, I can see that it cuts at 15. That's why I got P for the 15. So when the question says use the graph to find P and Q, you are supposed to get the gradient from the graph. You are supposed to get the gradient from the graph. You are supposed to find the gradient from the graph. You are supposed to find the y-intercept from the graph. Every question is going to be like this. So provided you linearize, or else you cannot use your graph to find P and Q. So get this into your head. You use the gradient from the graph. You use the y-intercept from the graph to find P and Q after you linearize. The last part, you got to use your graph to find the value of x. So basically, you need to be reading off your graph. But the reading off is not going to be so direct. It's not going to be so direct like your EMATH graph. You need to manipulate to get any of your axes. So you must get either a capital X or capital Y from your manipulation. So in this case, I am going to manipulate to a capital Y. So if you look, sorry, I'm manipulating to a capital X. So capital X is 5.5. After the manipulation, you go to your horizontal axis, look for 5.5. So look from your axis, you get a 5.5, and you look across. However, when you look across, you are not getting the value of x. When you look across, you are getting the value of y. So have you answered the question? No, because when you look across, you are getting the value of y. So from the graph, you are getting the value of y. You have not answered the question yet. So what I will do is I put it back into the original, into this portion. I put back the 9.5 into this part. So, and then I do a cross multiplication. And then I got to do my calculation to get my x. So this kind of question is not going to be like your EMATH graph where you read directly, you will get the answer. You need some form of manipulation depending on the axis. Okay, so I repeat, you always need to linearize. Linearization tells you the gradient and tells you the y-intercept. From the graph, you get the gradient, you get the intercept. And that's how you calculate the two unknown. If you totally miss this thing, you have no idea about this topic at all. This whole topic is just using the gradient and intercept to solve for unknown.